Hello, this is Mr. Wolf, and in this video we're going to be showing how you can use prime factors to find the lowest common denominator of two fractions. So here I want to compare two fractions. I have 5/8 and 4/6. Now, we went through a number of questions that we can ask to quickly come up with an answer. We would say, are the denominators the same? And they are not. We would say, are the numerators the same? And they are not. We would say, is one of the fractions more than a half while the other is less than a half? Well, half of 8 would have been 4, so 5/8 is more than 4/8. 5/8 is more than 1/2. Half of 6 is 3, so 3/6 would have been 1/2. 4/6 is more than 1/2. These are both greater than 1/2. So now what I want to do is find a common denominator and convert both of these fractions so we can compare them with like denominators. And it's sometimes a little tricky to figure out what common denominator to use. And we want to use the lowest one possible, the lowest common denominator. And the easiest way to do this is by breaking it into our prime factors. So I'm going to look at 8. I'm going to say 8 is the same as 2 times 4. And I know 2 is a prime number, but 4 can be broken further. 4 is 2 times 2. And so over here I'm going to say, oh, that means 8 equals 2 times 2 times 2. Now over here, I'm going to go to my 6. And I know 6 is not a prime number because it can be divided by 2. I'm going to think about it. 2 times something equals 6. Well, it's 3. And I know both of those are prime numbers as well. So over here, I'm going to say 6 equals 2 times 3. And now I want to be able to figure out what is a common denominator. And more than just any common denominator, what is the lowest common denominator? And to do that, I like including a Venn diagram. Now, if you don't remember how a Venn diagram works, each side is going to be for the things that only show up in one number, while the center is going to be for the numbers they share. So I'm going to start and I'm going to look for any numbers that I see that are shared between the 8 and the 6. And immediately I notice that they both share a 2. So I'm going to put the 2 in there in the center, and I'm going to cross it out from both of them. They shared it. It goes for both. Now I'm going to see, do they share this second 2? They don't. So I'm going to put that only in the 8 column. I'm going to cross it out because I've used it. I have another 2. It's not in the 6, so I'm going to put a multiplication sign and put it in the 8. And I'm going to cross it out. I've used up everything in my 8, and I can go over to my 6, and I still have a 3, which I know doesn't exist in 8. So I'm going to put it just in the 6 side of the Venn diagram. Now this tells us a few things. One is I can multiply everything in the inside to find the greatest common factor. The factor, the largest number that goes into both of them. In this case, it's just 2. 2 goes into 8 and 2 goes into 6. But the last thing is I can multiply across. I can say 2 times 2 is 4, times 2 is 8, times 3 is 24. And now I know 24 is the lowest common multiple, or for what we're looking for is the lowest common denominator between 8ths and 6ths. Once I know that, I can start getting to work to change my fractions from eighths into 24ths, and from sixths into 24ths. So now I've given myself a little bit of space to do some work. I know what denominator I want to change both of my fractions into, but I now need to do a little bit of math to figure out what the new numerator for both of these fractions will be if I'm going to convert the fraction's denominator. And as we said earlier, we know the identity property of multiplication. And that identity property says if I multiply a number by 1, it's not going to change. It stays the same. 5 times 1 is 5. 10 times 1 is 10. 1 million times 1 is 1 million. And so I can multiply a number by 1 without affecting its size. And that's exactly what I want to do. But I want to use fractions here to help me out. So I'm going to make my 1 into a fraction. And I'm going to try to think 8 times something equals 24. And because I still have my Venn diagram, I can go really quick because I can look at everything that is not in the 8 circle. So the 8 circle includes the two 2's that only go to the 8 and the 2 that is shared. But the 3 was only coming from the 6. And so that 3 is what's missing to make the number 24. So I found the denominator I need to multiply 8 by to make 24. But I had said we have to multiply by 1. So to make this work, I've broken my whole into 3 pieces. To have it stay as 1, I need to keep all 3 of those pieces. To make a fraction be equivalent to 1, we need the numerator and the denominator to be the same number. And now I can multiply across. 5 times 3 is 15. So I now know that 5/8 is equivalent to 15 24ths. They have the same value. They just look a little bit different. And I'm going to do the same thing now with my 4/6. I'm going to multiply my 4/6 by 1. And because I'm multiplying it by 1, its value isn't going to change. But if I multiply it by a fraction that's equivalent to 1, the way it looks will change. And I'm going to look back up here and say, well, my 6 had the 2 and the 3, but both of these 2's weren't in the 6. So 2 times 2 is 4. So that is the missing number in my denominator. 6, and I can check it. 6 times 4, yep, that is 24. Now I know I need to have the numerator and the denominator be the same for this to be an equivalent form of 1. So I'm going to put a 4 at the top to match the 4 on the bottom. I broke it into 4 pieces, and I kept all 4. And now I can multiply across the top. 4 times 4 is 16. And so I can now, instead of looking at 5/8 and 4/6, I can compare 15 24ths to 16 24ths. And I know 16 is greater than 15. And because they have like denominators now, because we found our common denominator, the numerator is all that matters. If 16 is greater than 15, then I know my 4/6 is greater than my 5/8. My 5/8 are less than my 4/6. Now the last thing I want to do is show you how this looks with fraction bars. So here I have 5/8 and 4/6 in fraction bars. And we can look at that, and maybe you look at that and immediately say, well, I could have just drawn the bars. 4/6 is more than 5/8. But look how close those are. And unless you are perfect at drawing fraction bars, there's a really good chance you could draw these in a way that makes it look like it's the exact same amount. And then you're going to get your answer wrong. But if you do the math, we're going to get the answer right. So now I'm going to look at this and say, I know that I can have the bars perfectly lined up if I make each of these have 24 equal pieces instead of this one having 8 and this one having 6. And to make this 24 equal pieces, I need to split each of my eighths into 3 equal pieces. And I need to keep every single piece I have. So I need to split them into 3 pieces. And now I need to make sure that I don't erase anything. I'm going to keep all 3 of those pieces I just made. And then we have to do that for my entire eighths bar. And now this bar that once was broken into 8 equal pieces with 5 of those pieces shaded in is now broken into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 pieces. And of those 24, 15 are shaded in. I didn't change any of the coloring. I just made each of my 5/8 split into 3 pieces and kept all 3. I multiplied by 3/3. And now I need to do the same thing for my 4/6. I need to take each of these pieces and split them into 4 equal pieces and keep each of those 4 pieces. So I'm going to do that for the first one. And notice that my 6th here has now been split into 4 equal pieces. And I've left all 4 of them colored in. Also notice that these lines are now matching each other. So I'm going to finish that up. I'm going to continue going. And I keep going even through the empty ones. And what I do there is if it had a line, if it was empty, I leave everything empty. If it was full, I leave everything full. I'm not changing how much was shaded in. Here we go. And each of my 6ths has now been split into 4 equal pieces. So I have now, instead of having 6 equal pieces, I once again have 24 equal pieces. And of those 24, 16 are filled in. And we can tell very clearly that this one is filled in while this one isn't. By multiplying the top by 3/3, by splitting them each into 3 pieces and keeping them all, and splitting this one into 4/4, splitting them into 4 pieces and keeping all 4, we were able to change the pieces so that they matched. This is how it works when we are multiplying by an equivalent form of 1. I hope this was helpful.